solve each equation. 1 plus 5 times the natural log of x minus 4 is equal to 3. First thing I'm going to do here is isolate the natural log factor. So I will subtract 1. I have 5 times the natural log of x minus 4 is equal to 2, and divide through by 5, and the natural log of x minus 4 is equal to 2/5, or 0.4. Now, since I have the natural log, I will turn this into its exponential form by exponentiating both sides of the equation with the base e. So I have e to the natural log of x minus 4 is equal to e to the 0.4. Using the inverse properties of exponentiating with base e and the natural log, the e to the natural log of x minus 4 is x minus 4. So x minus 4 is equal to e to the 0.4, and isolating x would equal e to the 0.4 plus 4. If we want an approximate value, we bring up the exponential, second e raised to the 0.4. Make sure to close that off before we add 4. So 5.492. The log base 2 of x plus the log base 2 of x plus 2 is equal to 3. So the first thing we're going to do here is to try and combine the two logarithms to a single logarithm using our properties. So since we have an addition of logarithms, I can write a single logarithm, same base, where I multiply the arguments of the two logarithms. So I'd have the log base 2 of x squared plus 2x equals 3. Now, I can exponentiate both sides of the equation using the base 2. So I'd have 2 to the log base 2 of x squared plus 2x equals 2 to the third. Using the inverse properties of 2 and the log base 2, this gives me x squared plus 2x on the left-hand side, and 2 to the third is 8. So now that's a polynomial equation. And x squared plus 2x minus 8 equals 0. That can factor as x plus 4 by x minus 2 equals 0, which implies that x equals negative 4, or x equals 2. Alright, now we have to be very careful here. We notice that x cannot equal negative 4, because if I substituted negative 4, I would have the log base 2 of negative 4. Negative 4 is not in the domain of that basic logarithmic function, so we have to exclude x equals negative 4. Log base 2 of 2 I can evaluate, and the log base 2 of 2 plus 2 is 4. I can evaluate the log base 2 of 4. So I can accept x equals 2.